Welcome to the Real Python Podcast. This is episode 96. Would you like to experiment with analyzing or manipulating audio with Python? This week on the show, we have Braden Riggs from Dolby.io to discuss extracting audio features and Python libraries for reshaping audio. Braden shares techniques from his recent talk at PyData Global titled Unlocking More from Your Audio Data. We share several articles, tutorials, and Python libraries to get you started working with audio. We begin with a quick introduction to digitizing audio and feature extraction. After discussing modifying audio files, we share tools and techniques for exploring audio analysis through data science. Braden talks about converting speech-to-text sentiment analysis and NLTK, the Natural Language Toolkit. He also shares a valuable collection of audio technology resources for developers. Python packages, including URL-lib3, have known vulnerabilities. Get a free t-shirt for fixing vulnerabilities by registering for the Big Fix at snyk.co. That's snyk.co/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Braden, welcome to the show.
Hey, how's it going?
It's going great. When you reached out to talk about coming on the show, it got me very excited. Most people probably know, based on the 90-odd episodes so far, that I'm kind of an audio geek. And so somebody coming from that background and having similar interests is definitely a fun topic. And so I thought we could make it a bit of not only an interview, but also a way to share how people could manipulate audio with Python.
Yeah, that sounds great. I love interacting with the audio community. And of course, I've seen your podcast before, so I thought it would be a great time to link up and maybe throw a few cool articles out there for anybody that hasn't gotten their feet wet in the awesome space of audio yet.
Yeah, totally. So you work for Dolby.io, and I have a lot of familiarity with older iterations of Dolby. Definitely tools that I used, tape machines and other things like that, have had that brand name on it, or standalone encoding, decoding devices and stuff. What is Dolby.io right now?
Yeah, it's a great question. I had the exact same thing. When I think of Dolby, I think of like cinemas. I think of the old VHS tapes that
Sure.
when I'd watch, it would, flash up Dolby and all that stuff. But Dolby.io is kind of like our answer to bringing a lot of that really amazing technology that makes cinema stuff exciting and putting that in the hands of software developers so that they can implement it into their apps and programs. And that sort of takes the form of two different suites of technologies. So our first suite is like our communications APIs, which you can think of as being used for video conferencing or building live streaming platforms and things like that. And then we have our media processing APIs, which are more focused around audio enhancement and transcoding and things like that. I spend more time focusing on the media APIs, but there is kind of that whole second side to the suite. So when I did reach out to you, it was to talk about, cool audio stuff, which is some of the stuff that we can do with media processing APIs.
Yeah, cool. Yeah, I was looking through the site and looking at some of the different things that you provide, and definitely of interest. And I think it's neat. I think I know of a couple meeting platforms that use the Dolby tools kind of underneath it. And I have definitely looked at the idea of having a tool that I can send audio to and have it process it and kind of send it back to me, which is pretty slick.
Yeah, definitely. It's just a lot of developer tools. There's all kinds of cool stuff that you can do with it. And I can talk more about that if you want. Otherwise, I'm happy just to talk about audio related stuff.
Cool. Yeah. Maybe we could talk a little bit about not like an entire history of your background, but like, why are you interested in audio and programming?
Yeah, that's a great question. So I originally got my start actually as a data scientist when I graduated last year from the University of California. But when I was studying my data science degree, I spent some time working in the cognitive science department, studying neural signal processing. And the cool thing about neural signals is they do share some similarities with audio signals. So a lot of the tools that I picked up and was working with to understand various brain functions also, works for helping us decompose audio signals so that we can remove stuff like noise. And of course, a lot of this stuff is done in Python, so it seemed like a really natural fit for me to get working in the audio space.
That's cool. So you're kind of taking this study of literal brain waves and move it toward audio waves in some ways.
Well, you'd be really surprised, actually. In the early days of like brain signal processing, they didn't have a lot of tools specifically for like neural signals.
Yeah.
So they had to use a lot of these audio tools that audio engineers use in order to remove stuff like noise, so they could isolate particular brain functions or try to find where a specific part of the signal is coming from the brain. So that's just kind of, a funny relationship that the two fields have.
Yeah. I mentioned this before. I'm trying to remember who with, but when I was working at the school for recording engineers, there was a newish software company that had created a product, and it was called Cool Edit Pro. That was the name of it. And it was able to work at incredible frequencies as far as something called the sampling rate. And I'll talk a little bit more about digital audio because that's a field that I taught for quite a while. And the fact that this new tool that they had created could, run at say 192 kilohertz and had like all these other more advanced, kind of cutting edge at the time tools, a lot of science interests were coming into it. Not that audio isn't a science in itself, but outside other kind of organizations were looking at it as a tool. And then what's funny, the story kind of ends with Adobe purchasing them, and that is the foundation of this thing called Audition now.
Oh, wow. That's super, super interesting.
Yeah. So it's kind of funny. Like these guys were really focused on like this pure deep level of like, what can you do with audio and how high resolution can you make it? And then do things like you're talking about. Like there's a thing called like a noise print where you can kind of analyze background noise of audio and then be able to process it out or invert it or whatever to make it kind of come out of the signal. And they were doing a lot of that stuff and demonstrating it to us, which was really fun.
Awesome. Nice.
I thought maybe we could talk a little bit about digital audio, just kind of get a general aspect of it, because as it moves into data science, it kind of changed a little bit. And so if someone was going to talk about digital audio and sort of this concept of bringing audio into a computer, again, like I had a big background in this, and so I won't go too far, but the fundamentals are that you have this analog sound like going into this microphone, and it basically creates this voltage signal. And the problem with that bringing it into a computer is that it needs to be turned into zeros and ones. And so there's this thing called an analog to digital converter, or ADC, that does that. And then it operates with two mathematical tools inside of that, a thing called a sampling rate and a bit resolution or bit depth. The sampling rate is kind of like a photograph of the waveform, where it was at that moment, what height and amplitude, if you've seen the picture of a waveform moving up and down. And it's that resolution sampling rate is going to continue to take pictures to try to capture how the thing's moving up and down across that. Each one of those photographs, if you will, these samples, has a amount of resolution or bit depth that is where you get the amplitude, or in a lot of cases, what that's going to do is show you like how loud or soft something is. So the first tool there, the sampling rate, is going to capture the frequencies. And there's some rules behind that. this thing called the Nyquist theorem, which somebody can research a little further. But a common number that you would see on these computers is 48,000 times per second or 44,100 times per second. That's what CDs used. And a lot of the idea behind that is that as long as it's twice the range of what you want to try to capture, in the case of human hearing, it's like 20 hertz, 20 cycles per second up and down, to 20,000 hertz is what human hearing, typically the range that we think of as perceivable, that should be good. We're going to capture everything we need. And so that sampling rate is pretty standard on a lot of equipment. And then there's other tools that try to go higher. Like I mentioned, Cool Edit Pro was able to work at like 192,000. And you might think to yourself, well, is that something somebody can hear or perceive? It's like those frequencies are there, and maybe human beings don't perceive them as notes per se, but that it actually does affect like the spectrum of like what you hear and the positions of things. And it's very interesting science, and we don't need to get all into the hi-fi high audio thing, which a lot of people get into, but the more resolution you have, the better. It's just like a camera in a lot of ways. And then the bit resolution has to do with basically how loud or soft stuff is. And you got typically the resolutions were 16 bits, which allowed for this certain amount of dynamic range. And then newer systems allowed for greater range, like 24-bit. That doesn't necessarily allow things to be louder. It allows for things not to be thrown away as far as the subtle, quiet areas of resolution where notes are sort of decaying down and so forth. And anyway, so that's kind of the raw stuff that's happening, the sampling and the resolution being captured. And then on the other side, to turn it back to play out your speakers, it has to go through a digital to analog converter, a DAC, a DAC, and that's how it comes back out. What's interesting to me is where data science comes in and says, okay, sure, we talk about sampling rate and bit resolution, but now how can we determine something more than just like this frequency is happening or this signal is this amount loud? And it gets into this idea that's pretty deep into the machine learning and that whole side. And that's why I want to turn to you and talk about the term, I guess, is audio features or feature extraction.
Yeah. Well, so I think one of the really amazing things about audio data, and I like to joke about this, is that it is actually kind of big data in its own way.
It's much larger than a lot of other stuff that we work with, like text.
Yeah, exactly. But people, sometimes forget that. A lot of people, I think, jump straight to doing computer vision related stuff, or they go and do natural language processing on the text specifically. But audio data actually has a lot going on in the background and the underlying bytes that make it super interesting. I joke that it's sneaky big data because it sneaks up on you, and how big that it actually is. So the challenge that we have is that we have these signals, right? Or we have all this data, right? That's stored in this sample rate and this bit depth. And our goal is to take what is all of this like raw, unstructured data and convert it into something that we can use to understand human words, or to understand like sentiment behind things that people are saying, or to understand what instruments people are playing, or to understand whether it's a child talking or an adult talking. And that process where we decompose these things is called audio feature extraction, which is quite similar to feature extraction that you see for a lot of other data types. But specifically, audio feature extraction is kind of like this necessary step in audio signal processing, where we take these small windows of the signal and we process or manipulate it to extract key features or indicators that tell us more about the underlying data. And it can also be used for stuff like removing unwanted noise and balancing time frequency ranges by converting digital to analog signals and a bunch of fun stuff like that.
To kind of pause you for a second there, when you're talking about moving beyond the individual samples, which don't provide a lot of information. It's just sort of a plot point. You're expanding this sort of window to look at sort of a chunk of audio, right?
Yes.
How much time is it looking at? Like, what's a typical area that's being identified or classified?
Yeah, so it can really depend on the context that you're using it in.
Okay.
If I remember correctly, humans are only able to recognize a temporal resolution of about 10 milliseconds. Like, that's as small as it can go.
Okay.
So anything smaller than 10 milliseconds, we're taking it out of the realm of what humans are able to comprehend and bringing it down to a level where machines are able to understand it.
Okay. And so in this case, when you start to do the extraction, can you set that time window?
Yeah. So there's kind of three different ranges, let's put it, that people work with. So there's high-level abstraction, mid-level extraction, and low-level abstraction.
Okay.
So high level is the easiest to understand because humans understand it. It's the level at which features are understood and enjoyed by humans. So think chords, melodies, rhythm, genre. Then there's mid-level, where we can perceive these features, however, they're not quite as well understood as something like melody. But these are things like pitch, beat, as well as like note fluctuations, things like that. And then there's low level, and these are purely statistical features that will be understood by a machine, but humans can't really understand or grasp them. And these are, buzzwords like energy and spectral flux and zero crossing rate.
Right. Okay. And so by pulling these features out, you can do kind of at a basic level, and we'll talk about some tools and we'll talk about some libraries and a few articles to kind of get people started if they're interested in this stuff. By looking at this, having the computer do it, you could do something like, say, find the silence in an audio track and say, okay, I want to remove those large gaps of silence.
Yeah, absolutely. And in fact, that's a great example to start with, right? Like, we can see when decomposing this signal, regions where there is little to no noise recorded, and then there's regions where there's a ton of noise recorded. And we can use these features to build a tool that can rip out all those segments and remove any awkward pauses or whatever. But it can get like a lot more advanced than that. You can actually break it down to build something that can tell the difference between instruments or tell the difference between speakers, or whether, one speaker is perceivably more agitated than the other speaker, or all kinds of complex, really cool stuff.
Yeah, I thought that was pretty interesting. And I think we'll kind of provide lots of off-ramps for people to say, that's what I'm interested in, and go explore.
Yeah.
Did you know that 47% of Python projects include known vulnerabilities? And there are vulnerabilities in even the most popular packages, like urllib3. Luckily, 87% of Python vulnerabilities can be fixed. The Snyk team is hosting The Big Fix, an online event where you can earn swag for fixing vulnerabilities. Plus, get hands-on support from security experts during the 24-hour live stream on February 25th. Register at snyk.co, that's snyk.co/realpython. I think we kind of covered some of the background of it, and maybe we can kind of get into some of the tools. And as I was looking at the resources that you shared with me, I kind of went on my own little journey and found really neat stuff. And so in a talk that you had, you were mentioning a library called PyAudioAnalysis. And I'll just say Theodorus. He's got a very interesting, it looks like possibly Greek name.
Yeah, he is. I think he does work at a Greek university.
Yeah. Anyway, so he created this kind of overarching tool that seems to maybe combine the resources from a few other tools. And I'll let you talk a little bit more about it, but I really like that he created this article and he put it up on, is it Hacker Noon?
Mm-hmm.
And the article is titled Audio Handling Basics, Process Audio Files in Command Line or Python. And so I think a lot of our listeners, if they've done anything with audio, maybe they've made an MP3 before, or they've converted a file or renamed something. They might be familiar with a really common library that's out there that's called FFmpeg. And it's a free open source project that's out there for sort of doing the multimedia, low-level stuff inside your computer to kind of manage audio. And then a lot of libraries are built on top of it to make it friendlier and make it, do something with, say, Python. And this article is great. It really goes into lots of examples, starting with, okay, let's do some command line stuff of like, let's take the audio out of an MKV file. Let's change the sample rate of something. Let's make it smaller or potentially, truncate it. And he starts to get into a couple other libraries, and that's where I might dive out a little bit and talk about this one that's called PyDub, Pydub. And again, it has a dependency. It requires that you have FFmpeg or libav installed on your machine. I also like this really interesting note that he has about the library, that it is going to, like we were talking about feature extraction, it does this thing called an audio segment, and it creates these audio segment objects. And the handling of them is interesting because they're immutable. And like strings in Python, you can modify a string, but it can't basically do it in place. It needs to be put into another string. So I'm guessing that's the exact behavior here, is that you can modify this audio, but if you want that result, it's not going to save over the, in-memory version that you have. You have to kind of copy it into a new object if you're doing those kind of modifications, which I thought was kind of interesting to kind of keep aware of. But it gets really into the idea of like, okay, do you want to slice audio? Do you want to concatenate two pieces of audio together? Do you want to crossfade them, loop them? And so I'll include the links to the PyDub GitHub project, and that one's from James Robert. It's going in some really interesting directions that are interesting to me. And I think it's funny because there's like this whole area that says currently undocumented, a whole area for playback in case you need to have it playing back kind of as you're working, but then also signal processing of doing things that you might want to do to sound, like compression or equalize things to adjust the treble or bass kind of stuff, normalize the audio, bring it to the maximum level, change the speed. So there's a whole sort of sub-library of PyDub effects and PyDub SciPy effects. And then he also has signal generators, like creating sine waves, square waves, sawtooth, and then a whole effect registration system, which goes way back to an early episode that I was talking about using decorators. And it sounds like he's having an effect registration system using decorators. So these are not documented in his stuff, but these features are kind of being worked on. And I found it really kind of fascinating. You had shared some of this with me. Do you have a chance to check out this article?
Yeah. And actually, just as a second advocate for the article, I do think it's really good. I think the problem with a lot of getting started with audio guides that you find on the internet is that a lot of them will just take an audio sample and convert it to transcription.
Yeah.
And then do the analysis on the transcription. But kind of as we talked about before, audio data is this incredibly rich data source. And in just extracting the spoken words from an audio sample, a tremendous amount of data is kind of lost there. And that's data that you can do all kinds of really cool stuff with. So I really like that this Hacker Noon article actually tries to focus more on the fundamentals and take you through the whole process that is working with audio data, rather than just skipping all those steps and going straight to a transcription.
Yeah. He also does some kind of fun stuff, like we talked about earlier. Let's say you want to remove the silence from a speech or something like that. In your case, that would make the file much smaller as far as like, processing it, working with it to remove these chunks of silence that are there. And so he has an example where he's taking a speech and removing based upon like a certain threshold, like, okay, when the sound dips past here, I'm going to go ahead and remove it. And in this case, it's a little coarse. And so I could kind of right away like start to think to myself, okay, well, this is where I would start to adjust it to kind of make it not so it's sort of eating certain words and the remove those low energy segments of the speech. And so he has examples, which is nice also. So you can kind of get an idea of like, what you should be getting. And anyway, it's a really cool article.
Yeah, definitely recommend for everybody to check that out. And of course, he's also the author of the Pi Audio Analysis Python package, which I've had a tremendous amount of fun using, which aims to take a lot of these really complicated audio-related concepts and boil them down into a couple simple-to-use tools that you yourself can use on audio samples. And so as we're kind of talking about feature extraction before, the package makes that whole process really simple, where you can run a batch feature extraction job on a whole directory full of audio samples. And from that, you can then be given a ton of interesting data points for things like zero crossing rate, energy, the entropy of energy, all which you can then use to cluster or segment or train various models or do all kinds of cool stuff with the underlying audio files.
Well, maybe that we could lead into that, and I could kind of share some other tools a little later as we keep going. But now that you kind of mentioned it, that makes me interested in one of the examples. You had given a talk at PyData Global 2021, and it was titled Improving Automated Ad Insertion with Audio Analysis. You were using kind of a mix of tools. One of the examples that you had given in the talk that I thought kind of leads from what you were just saying is you were saying, okay, how could we identify the type of podcast this is? And it didn't quite go into the specifics. And what I mean by that is, were you, in the example, you were trying to compare or I guess identify through modeling, is this a sports podcast or a business podcast? And so I was kind of wondering like a little more details, like, okay, were you taking 3 minutes of each podcast and then building your model and using this sort of feature extraction to kind of find things? Like, can you explain a little bit further there what was happening?
Yeah, no, absolutely. So the context was I was presenting this talk at PyData where I was showcasing some of my favorite audio tools. And this package came up for feature extraction. So I want to, find a good example to show when feature extraction can be super useful and also kind of fun. So I took a selection of sports podcasts and a selection of business podcasts. So I had 10 sports podcasts, which I trimmed all down to 20 minutes.
Okay.
And then I had 10 business podcasts, which I also trimmed down to 20 minutes.
These were all different ones? Like they weren't all episodes of the same show. They were from the genre.
Oh, no. So sorry. They were actually all episodes from the same show.
Okay.
So one of them was a specific football podcast. And then the other one was a just business management podcast. And I picked those two because in my mind, I thought that those are two different genres that are quite distinct from one another.
Yeah. I could imagine them having different energy, if you will.
Yeah, exactly. And so the goal was to see if I could prove that using feature extraction on the audio signals themselves.
Okay.
And so I did actually use the Pi Audio Analysis package. And what I did was I created these feature vectors for each of the different podcasts. And then built into the package is this classification and segmentation tool, which we can use to see if there are any underlying or natural differences between the podcast and how it's mastered and who's talking in it and what they're talking about. And then another podcast and how it's mastered and what they're talking about, etc.
So this one is actually going beyond some of the pure audio things that you're mentioning there, like the energy level, the way it's mastered, like, like how loud the signal is compared to like the two of them, and getting into actually pulling words out also?
So not quite at this stage. We're working. So if we're talking about time frames again, we're actually at the low level abstraction of the audio file. So we're looking purely at these statistical features that we can extract from the audio that might not necessarily be intuitive to humans, but we can use to train a rudimentary classification model.
Okay.
Which can maybe tell the difference between what constitutes a sports podcast and what constitutes a business podcast. Now, of course, in this example, it's a really simple one. We have a very small sample size, and we're really just trying to see if there's any way that we can draw a line between a sports podcast, or to be more specific, these sports podcasts,
right,
and then these business podcasts. And just by extracting those basic features, we were able to distinguish between them. The way that we were distinguishing between them was likely more to do with how these podcasts were mastered.
Or even edited in some ways, like the pace of them and things.
Absolutely. And just, the quality of the microphone that one team was using versus another. So it was able to separate the two podcasts based on, really even rudimentary features such as loudness.
Okay, cool.
But it was kind of a cool example to more showcase the versatility of the underlying package. And then to just show that even though to our ears, the podcast can sound relatively similar in terms of volume, in terms of quality and how they're mastered, when we take this down to this like really low level of abstraction, there are differences that a machine is able to see that we can't see.
Right. We could potentially sense if we're told to pay attention to, but it's going to do a much better job of actually defining that.
Yeah. Absolutely. And if I want to make it a more empirical investigation, of course, I would have to pull in hundreds of podcasts, hundreds of business ones, hundreds of sports ones,
sure.
do all that stuff.
Right. Expand your model. Yeah.
Yeah. Whereas in this case, it was more kind of just meant to be a fun example or a fun showcase to just show how this tool worked, and to get people thinking about what some broader applications of these features that we've extracted might be.
So from that talk, you shared you had a notebook you were working in, is that right?
Yeah, absolutely. So we shared that. It's shared to my personal GitHub.
Yeah, we'll include that as a show note.
Yeah, and then the tools themselves that I used are also included in a really awesome public GitHub repo called Dolby.io Awesome Audio, which you can find on the internet. And we're actually looking for contributors for that. So if anybody does have any tools where this is a great audio tool, or this is a great audio resource that really helped me learn about this topic, or here's this great community forum that I want to share with other people, we do have that resource. We are looking always for people to add their own cool things to it.
Is it, I guess, two things there. Is it Python specific, or is this generally like other types of tools could be included?
Other types of tools can be included. For the moment, it tends to be pretty Python centric.
Okay.
However, we do have some tools for R on there, some tools for MATLAB.
Okay.
So it really is actually just open to anybody that finds any of these cool resources and wants to share them with the broader community.
Sure. That's kind of a trend that's out there. I don't even know how long it's been around, but the idea of like an awesome list sort of,
yeah,
depending on the topic. That's great. Nice. There's a much deeper topic that I know you want to kind of get into that is further on in your talk. And I thought maybe I'd switch over and talk a little bit about another one of the libraries that were mentioned in the Hacker Noon article. It's called Librosa, Librosa. This one does some of the stuff that PyDub does, but it actually does a little more of like what you were talking about, where it's going to go and do more like extraction of features and find things. And I feel like if you were interested in analyzing, say, the musical content of something, like let's say you're interested in finding out what tempo something was run at and where the downbeats of particular music is playing in this particular audio example. And they give really cool resources and a really nice guide online with a set of tutorials for this library. I was really impressed with it. It has examples of doing something like that. Okay, like let's figure out exactly where the beats are in this thing. And you could actually do the math to say, okay, this is running at 127 beats per minute or what have you. And then it also has things like, it's called HPSS, harmonic dash percussive sound separation. So the idea of, is this simply percussive elements or are there harmonic elements inside of it, like something like the sound of chords of a guitar playing versus the percussive elements of the drum, being able to kind of extract which is from there. So this library would be a great jumping off point to start to think about, as opposed to going into analyzing spoken word, but actually analyzing musical content. Like if you were thinking about how does Spotify or some of these other kinds of things get a brand new audio track and say, is this something that someone else would enjoy? Does it have the same kind of energy? Does it have the same kind of beat? All these other kinds of characteristics that would be metadata that could be extracted out of it that isn't necessarily like written in the file, as true like a metadata like attached to it, but can be extracted out of it. And I think it's really kind of cool. And then it also kind of gets into time and frequency and a couple other tools in there for like, if you wanted to stretch audio out. I don't know if that's something you've ever had to do where you like, in the case of like podcasts, you might want to make things, I don't know if you do this, but I listen to like audiobooks and podcasts at a higher speed. I'm guessing some people might not do that for this podcast because I talk fairly fast. That's a nice tool that's, part of that whole audio processing that you can do. And then same with that, like pitch shifting. My wife makes tutorials for this company she works for, and they told her that they wanted her to sound happier and more energetic. And one of the ways that they suggested was to pitch shift herself up so she sounded like she was speaking at a higher timbre, which I thought was really weird, but I guess it worked for them. So anyway, Librosa is a really neat tool and lots of great utilities and really well documented API. So again, another tool that you can kind of play with if you want to lean more on the musical side, all the way to being able to look at the sonic qualities in like graphing, like they call it a chromogram and things like that. This week, I want to shine a spotlight on another RealPython video course, and it includes several of the libraries that we discussed this week. It's titled Playing and Recording Sound in Python. The course is based on a RealPython article by Joske de Lange, and instructor Joe Tatusco shows you how to use some of the most popular audio libraries to play and record sound using Python. By the end of the course, you'll know how to play MP3 and WAV files, as well as a range of other audio formats, play NumPy and Python arrays containing sound, record and manipulate sound using Python, and save your recordings as audio files in a range of different file formats. I think exploring how Python can work with audio is not only fun, but also a great way to explore the creative side of Python. And it can help you add a whole new set of multimedia features to your projects. And like most of the video courses on RealPython, the course is broken into easily consumable sections, has code samples for the techniques shown. All courses include a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. Kind of going further on one of the topics that's in your talk is the idea of speech to text analysis. What were you using in your talk for that?
Yes. I know I spent a little bit of an earlier part ragging on the fact that a lot of basic tutorials out there just go straight to generating transcriptions or speech to text from the spoken audio. But of course, that ability to do that is incredibly useful. So, for a bit more context around the goal or the project that I was kind of getting to in the talk, pretty much what I was trying to do was I had all of these podcasts and I was trying to come up with a better, more natural way to algorithmically insert advertisements into the podcast. So I'm sure everybody's had this experience when you're listening to a podcast on a certain platform. Some of those platforms will just drop an ad right in the middle or right in the middle of conversation and just cut out straight to an ad.
Right. Yeah.
Or YouTube videos are a particularly egregious example. You can be watching somebody and like 20 minutes in, it just cuts in to this random ad for a product that is vaguely related to you. And so my goal with the project was to find a more organic way to insert advertisements into podcasts. And by organic, I kind of had three criteria that I wanted to use, right? The first criteria is that the advertisement should be relative to the conversation occurring near it.
Okay.
Right. So if I was using sports podcasts. So in the sports podcast, if they're talking about a particular basketball team, it makes sense for an advertisement related to that basketball team's merchandise or tickets to kind of be around the area. It's relevant to conversation, whereas an ad for car insurance might not necessarily be relevant. The conversation should also be positive for the advertisement. So we can't have the hosts, ragging on the performance of a basketball team and then, throw an ad in for season tickets, right? That's not a compelling call to action. And then the third criteria is that the advertisement should not interrupt the flow of conversation. So it shouldn't just be when the host says a particular basketball team name that bang, there's an ad right there. No, we want it to come in at kind of more of a natural pause or a lull in the conversation around after the time they've mentioned it.
Okay.
A big part of this, of course, is understanding what the podcast is talking about. And for this, we need to get a transcription of the spoken words, right?
Right.
And there's a bunch of different tools. I'm not particularly a fan of any one in particular. For this particular project, I used Azure Cognitive Services Speech to Text, which is a paid speech to text tool. However, it's also in my GitHub. There is a free option in the form of Pocket Sphinx, which actually was originally developed for apps. And that is just a freely available speech to text tool.
Okay.
Now, of course, using a paid option comes with some advantages, like the fact that it's all done up on the cloud, which definitely runs a lot quicker than my poor old ThinkPad, compared to the Pocket Sphinx option. But also the Azure Cognitive Services option includes a lot of customizability. You can use and import different models to analyze it, as well as get like multiple transcriptions of the same segment of audio where you can select out the one that works the best for your circumstances.
Okay.
So then once we have the transcription, we're then able to sift through the transcription to find the specific mention of organizations such as the Bucks, which are a basketball team. Now, to do that, I actually used a tool which I'm sure a lot of people have at least heard of in some form, which is the Natural Language Toolkit. And since we're sharing some articles that we find useful, I actually have one that I've read from RealPython, which I went back to because I thoroughly enjoyed the article. I thought it was a very concise and to the point explanation of the natural language toolkit.
Yeah, that's from Joanna Jablonski, and she's been on the show a couple times, and it's a really good introduction to NLTK, the toolkit, and kind of a lot of the fundamentals, so you can kind of get started and know where where to get going with it. And I was impressed with the depth. Like many of our articles, it really goes pretty far to get you going.
Yeah, so it was a really great starting point for me, where I was then able to use some of the tools in the toolkit to extract organizations. Specifically, in this case, it was a sports podcast. I picked basketball teams. So I went through and found the basketball teams with it. And then there's another tool in the package, which is their sentiment analysis suite of tools. Of course, one of the criteria is that we want to make sure that if we're going to insert an ad about a particular organization, we don't want them saying anything poor about the organization. Otherwise, it's not going to be a compelling advertisement for the viewer. So to do that, we performed sentiment analysis then on the text around when they mentioned the organization. And for anybody familiar with sentiment analysis, you'll know that there are a ton of different models and packages that you can use. I specifically used a model called VADER, which is Valence Aware Dictionary for, I want to say, sentiment reasoning. Can never remember the acronym. But anyway, it's just a really rudimentary introductory model that essentially assigns every word a score on a spectrum of negative to positive. Really, again, just basic, but for the purposes of this demonstration, I thought it was sufficient. So we would take all of the words around when they mentioned the organization and explore whether they were talking about the organization in a positive sentiment or a negative sentiment. So once we confirmed that we were talking about it in a positive sentiment, we could then move on to finding a way to insert the advertisement in a way that felt natural.
Okay.
So to do that, this is kind of where it relates a little bit more to what I do over at Dolby.io. So as I mentioned earlier, Dolby.io has a suite of media processing tools. Specifically, we have some tools that produce metadata relating to the audio. Metadata as well as just interesting insights into the underlying audio signals. Specifically, we have an API. It's our Analyze API. And it allows the user to explore things like speaker diarization, which is where you break out the number of speakers in a particular audio segment in order to discern kind of who's talking when.
Right.
So if I was, to run it on this audio recording, for example, it would find that there are two speakers and it would show when I'm talking, when you're talking, and when there's silence.
Yeah. Okay.
Using that package, I was then able to take this audio sample where we, one, knew that the audio sample was mentioning an organization, specifically the Bucks. Two, that they were mentioning it in a positive tone. And three, try to find a location where we could then naturally insert this ad. So by using this tool, we were able to break out who was talking when, as well as when the silent segments are. Now, silence doesn't sound like a big deal, but as we kind of alluded to earlier, having silence in your audio recording is kind of like wasted space if nothing's going on there. And in fact, in a professionally produced podcast, having silence in there for, a duration that is above the natural threshold that we feel about, thinking like an unnaturally long pause, we actually kind of want to get rid of that. So using the API, I wanted to find a location where after they've mentioned the organization in a positive tone, where we could then insert the ad into the segment where there's a natural pause in the conversation, where this silence occurs. And so using the API, it points out and finds these locations where nobody's talking and there's a bit of a natural pause. And so I would set a threshold. All right, we need to find something that works within 15 seconds after they've just mentioned that organization, as to make sure that it's like not too far out in the podcast where it doesn't become relevant anymore to the discussion, but also to make sure that we're not inserting it at an awkward moment. And that's kind of what the presentation all led up to. Was then it was able to, using all of this different data that we collected about just one sample of audio, we were able to identify the organizations present. We were able to understand the tone of certain segments of the podcast. And then we were able to find a more natural moment to insert the audio. And I didn't have an advertisement to use, but we showed an example of it where you could insert it. And yeah, and it was kind of more just like a proof of concept to show how audio data can be used for some really interesting creative things. You know, I'm not exactly passionate about automated advertisement insertion in podcasts, but it is, of course, a very industry relevant example.
Yeah, it's a very interesting problem to solve too, which is kind of fun to go through the steps of like, what am I looking for as far as features? You know, I need to worry not only about the pauses and identifying the different speakers, but also like the sentiment of what they're talking about and a specific mention of a particular word. So yeah, it's a neat problem to solve, again, no matter how we necessarily feel about it. I honestly had my own weird kind of feeling reading some of these articles, and I went down a little bit of a hole learning a little bit about Pi Audio Analysis. And the guy who created it, he works for a company that makes tools to figure out how people are, like their emotional state by listening to their audio. And one of the tools they have created is a tool for like customer call centers to try to match an appropriate person to how that person sounds as they're calling in. And I'm like, I don't know how I feel about that. You know, I guess if you don't know it's happening and it all turns out well, then maybe that's okay. But it seems like kind of a strange thing. And that's, I feel like one of the areas of data science that's always kind of a interesting thing. Like, yeah, we can use these things for good or bad. And so it's, intriguing problems to solve, and then always kind of like, well, you know, why are we solving this, and you know, what are we trying to do with it? But I definitely thought it was an interesting set of things that they're creating there.
Yeah, absolutely. And you know, using the exact same tools, there's other less corporate kinds of examples that you could do. You could mess around with things like one of the projects I haven't had a chance to work on it, but I feel like it is possible, is I'd love to create some kind of tool that is like almost like an auto highlight detector. So it's like when you're watching like a live stream and there's a really cool 3 or 4 minute clip from that live stream that kind of goes viral or something. What if you could use all of these, you know, same tools that I outlined to try and find an exciting segment of audio like that, based off of when everybody all of a sudden gets really loud and when everybody gets really positive really fast, or you know, I don't know how it would work, but yeah, it's another example of kind of the fun little projects that you can do with this sort of stuff. Yeah,
definitely. That's funny. I had a friend, I don't know how you come down on this. I feel like different people have different ways of listening to music. And I feel there are people that have always listened to entire, like you could think of them as an album or a CD. They would listen to them from beginning to end. I'm not that type of person. I'm more of a song person. And so I will listen to very specific songs. And I like to shuffle them and play them in different orders, and always kind of enjoyed that. More like a DJ kind of thing where they're selecting different songs and programming to go together, as opposed to like it has to be the album. But I had a friend and he would always like stop and then play me like a very specific moment in a song. And it was like, oh my God, you got to listen to this part. It was all about the individual parts for him. I always thought that was kind of okay, I guess there are people that are like that too. Like, all right, wait, you got to hear the good part. So I don't know where you fit in there, Braden.
Yeah, well, I mean, that definitely sounds like an exhausting way to listen to music, right? You've got to always be jumping around, finding your favorite little parts in them.
Right. Yeah. So Braden, I have these weekly questions, and the first one is, what is something that you're excited about in the world of Python?
For me personally, my favorite part about the Python community, is the Python community itself. So I'm really looking forward to PyData Berlin, PyCon and PyData Berlin. They've kind of merged into one, given the circumstances. And that's coming up in April. So I'm really looking forward to that. For now, it's still slated to go ahead in person. However,
okay.
We'll see how that plays out. But I love the event, so I'm absolutely looking forward to that.
Sure. Have you submitted a talk for it?
I actually haven't. For this one, I'm going to just kind of watch and learn more. I found that when I presented at PyData late last year, I spent so much time focusing on my presentation, because I want it to be good, was that at the time I wasn't able to enjoy the community as much as I would like.
Yeah, I'm sure.
So then it was kind of me more catching up on a lot of the talks that I did want to watch live. I instead had to watch when they were recorded.
Yeah, that makes sense. Yeah. So my next question is, what's something that you want to learn next? And it doesn't have to be Python specific.
Yeah, that's another great question. Recently, I've been working a lot in JavaScript. So I'd love to pick up a new JavaScript framework. Specifically, I was looking at Svelte or Vue.
Okay.
Which, I haven't had a ton of experience with JavaScript, so I'm excited to learn more about all that stuff. And I'm also excited to maybe get to work on some more stuff in the app space. So picking up a tool like Flutter is also on my radar for something one of my resolutions for 2022 is to try out both those tools.
Yeah, I had somebody recently very interested in that space too, and I think mobile stuff is just amazing, and kind of the idea of maybe making some of these tools audio types of things that can be on portable devices. I really would be interested in that too. So that's neat.
Yeah, absolutely.
Yeah. Do you have any shout outs or plugs that you want to give here at the end?
Yeah. For anybody that is interested, I'll bring it up again. We have this awesome audio repo on GitHub. So anybody that does feel like they have some tools and want to contribute, you're absolutely welcome to contribute. Or for anybody that's kind of just looking for a central space where they can poke around and just learn more about audio and audio analysis and get connected in the community and all that stuff, please go check out the repo.
Okay.
For anybody interested in any of the tools that Dolby.io is creating, please feel free to reach out to me on Twitter at BradenRiggs1. I'm always happy to answer questions, chat about general stuff. I'm happy to talk all day about Python stuff if anybody wants to do that with me.
Sure.
Yeah, or just to connect up and share any of the exciting stuff happening in the community. I'm available there for that.
All right. Well, Braden, I really want to thank you for coming on the show. It's been a lot of fun.
Yeah, no, it's been an absolute pleasure, Christopher, and hopefully I'll maybe get to do it again someday.
Yeah, definitely. All right, thanks. And don't forget, if you want to fix your vulnerabilities and get a free t-shirt, register for the big fix at snyk.co/realpython. That's snyk.co/realpython. I want to thank Braden Riggs for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.